Hello everyone, welcome back to a new session. In our previous sessions, we have learned about lens formula and Cartesian sign conventions and how to apply Cartesian sign convention in solving various lens formula related numericals. If you haven't watched those videos, please watch those backup videos. If you like it, subscribe to our channel and hit the bell icon for new videos as notifications. Once you study a formula or a concept, how do you access yourself, your ability to apply the same thing in solving numericals? Let's do it today by solving previous year's ICSE board questions. So without any delay, let's begin. Let's start with year 2020 question. The question is here. A lens of focal length 20 centimeter forms an inverted image at a distance 60 centimeter from the lens. First, identify the lens. Second, how far is the lens from present in front of the object? Calculate the magnification of the image. So question year 2020, this is a lens formula related numericals. It is being asked for 4 marks. A lens of focal length 20 centimeter. The focal length of the lens is given. Focal length is 20 centimeter. Clear? Okay. Forms an inverted image at a distance 60 centimeter from the lens. The image distance V is given 60 centimeter. Okay. So we don't know what is the lens here. Once you know the lens, you can apply the Cartesian sign convention. The first part of the question is identify the lens. So the answer is there in the question itself. The hint is given. Lens forms an inverted image. Since the image is inverted, what type of lens it will be? The nature of the lens will be always convex, because only convex lens can form an inverted image. So I can write as the image is inverted, lens is, the given lens is convex in nature. Clear? So inverted image. A convex lens can only form inverted image. Please remember it. Okay. Once you understood the lens is convex lens since the image is inverted. Now you can apply the sign convention here. The focal length of a convex lens is always positive. So plus 20 centimeter. And image distance is 60 centimeter. Since the image is inverted image is formed on the other side of the lens. For example, this is the lens. Optical center, focal length f1 is 20, okay, and f2 is 20 here. Clear? 20 centimeter, and this is 2f1 and this is 2f2. So an inverted image is formed about 60 centimeter, about somewhere here. An inverted image is formed, okay, here A dash B dash. This is the inverted image, is formed somewhat 60 centimeter, okay, on the other side of the lens. Since it is to the right of the lens, it will be plus. Clear? Since it is on the right side of the lens, the image distance is taken as positive. And object distance is, object is somewhere here. Okay, we have to calculate the object distance. This is the object distance. Object is standing here, AB. The object distance we have to calculate, we don't know the object distance. So all the distances are measured from the optical center, which is considered as the origin of the lens. Clear? Okay, let us begin. So V is plus 60 centimeter. Okay, now let us apply the lens formula. We know the lens formula, 1 by F is equal to 1 by V minus 1 by U. What do you want here? We need, in the second part, you have to calculate how far is the lens present in front of the object. So we have to calculate the object distance, the distance between the lens and the object here. Okay. So 1 by U is equal to 1 by V minus 1 by F. So all the values are there. Place the given values in the formula. 1 by V, 1 by 60 minus 1 by F. What is the value of F? That is 20. Taking the LCM of 60 and 20, that is 60, 1 minus 3, that's equal to 1 minus 3 minus 2 by 60, that comes out to be 1 by u is equal to minus 1 by 30. So u is equal to minus 30 centimeter. Clear? So the object is placed at a distance 30 centimeter in front of the lens. So we are getting the object distance as 30 centimeter. So this distance u is coming minus 30 because the object is always placed in front of the lens. It is to the left of the lens. So it is taken as minus 30. By calculation we are getting it as minus 30 centimeter. Okay. So the object distance we got it minus 30 centimeter. So that's the second part. Second part is over. Now the third part of the question. What is the third part of the question? You have to calculate the magnification of the image. So let us calculate the magnification of the image. What is the formula for magnification? Magnification m is equal to v upon u. You know the formula. Place the values. V is plus 60 divided by u is already we got it minus 30. So it comes cancelling, we get minus 2. So the value of magnification is minus 2. Clear? Since image is inverted, the magnification will be always negative. Clear? So steps are clear to you. So we identify the nature of the image, nature of the lens, convex lens, then applying lens formula, we calculate the object distance, and the last we calculate the magnifications. Steps are clear to you? Okay, fine. Now let's move on to year 2019 board question. A virtual diminished image is formed when an object is placed between the optical center and principal focus of a lens. Name the type of the lens which forms the above image. Draw a ray diagram to show the formation of the image with the above stated characteristics. Okay. So what is the question? A virtual diminished image is formed. So we have to find the type of the lens. So as you know, a concave lens can form only virtual, erect and diminished image. Clear? So a concave lens can form virtual, erect and diminished image. So the given lens will be concave in nature. Concave in nature. We can definitely write the answer since a virtual diminished image is formed only by concave lens. Clear? Now the second part, you have to draw a ray diagram to the formation of the image with the above stated lens. So using a concave lens, we can draw a ray diagram. So you know, in case of a concave lens, make a concave lens, mark its optical center, principal axis, f1, 2f1, f2 and 2f2 equidistant from the optical center on the other side of the lens. So you know, in case of a concave lens, for any position of the object, irrespective of the position of the object, a concave lens always forms virtual diminished erect image. Clear? So let us place the object between f1 and O. Let us try to place the object between f1 and O, optical center. An object is placed AB, a ray of light traveling parallel to principal axis. After refraction it will diverge, and if you produce it backward, it appears to be coming from the principal focus, and a ray of light traveling through the optical center passes undeviated. Clear? So applying the rule, you are getting the image, the point of intersection here. So you are getting the virtual erect and diminished image A dash B dash between optical center and principal focus. Clear? So by following the rules for construction of ray diagram, we are getting a virtual erect and diminished image. So remember, in case of a concave lens, irrespective of the position of the object, concave lens always form virtual erect and diminished image. Is it clear? So the second part is over. It's a 4-mark board questions. So 1 mark, another 1 mark. What is the third? Another question, let us see. Let us check it. An object is placed at a distance 24 centimeter in front of a convex lens of focal length 8 centimeter. What is the nature of the image so formed? calculate the distance of the image from the lens and calculate the magnification of the lens. So another part of the question, an object is placed at a distance 24 centimeter in front of a convex lens. So in case of a convex lens, the object distance is given, it is 24 centimeter. You know, as per the sign convention, object distance is always taken as negative. So mark it as negative. Okay, of focal length 8 centimeter. The focal length of the convex lens is always taken as positive plus 8 centimeter. Clear? What is the nature of the image so formed? Let us try to draw a ray diagram to this problem. Okay, consider a convex lens, its optical center, principal axis, okay, O, f1 at 8 centimeter, 2 f1 at 16 centimeter. So this is the focal length is 8 centimeter. Clear? And f2 and 2f2 equidistant on other side of the lens. So the object is placed at 24 centimeter. 2f1 it is 8, 16, distance is 16. So the object is definitely standing beyond 2f1, an object is standing beyond 2f1, an object AB. Are you following it? Okay. So what is this object distance? It is given. This object distance from the optical center, that is U, is 24 centimeter. Since the object is standing left to the lens, it is marked as minus 24. Clear? So a ray of light traveling parallel to optical principal axis, after refraction it travels through the principal focus, and a ray of light traveling through the optical center passes undeviated. So we are getting an image here, somewhere here between f2 and 2f2, a dash, b dash. Clear? So now we can write the nature of the image. What is the nature of the image so formed? So from the diagram we can clearly write the image is real, inverted and diminished. Clear? So for an object placed beyond 2f1, a convex lens forms real, inverted and diminished image formed between f2 and 2f2 on other side of the lens. So the first part is over. The nature of the image is real, inverted and diminished. Now what you have to do there? Calculate the distance of the image from the lens. So this distance, the distance of the image from the lens V, this is unknown. So V is unknown to us, we have to calculate. So how can you calculate V when all these quantities are available to us? With the help of lens formula. So let us apply lens formula. So in second part, 1 by f is equal to 1 by v minus 1 by u. We want 1 by v, right? Therefore 1 by v is equal to 1 by f plus 1 by u. You transported u to this term, so minus become plus. Now apply the sign convention. So that's equal to 1 by v is equal to, we can write it here, okay. So 1 by f, what is 1 by 8 plus 1 by u, 1 by minus 24. Clear? So taking the LCM, 24. Alright, 24, 3 8s are 24, minus 1. So that's equal to 3 minus 1, 2 by 24 comes out to be 1 by 12. So 1 by v is equal to 1 by 12. Therefore v is equal to, I can write 12 centimeter. V is equal to 12 centimeter. So what's the value of v? So the image is lying at a distance 12 centimeter in front of the lens. Clear from the diagram? Okay. So since it is right of the lens, v is coming out as positive. By calculation, by applying proper sign convention, we are getting the exact answer, 12 centimeter. Alright? Okay. Now in the third part, I can write here, you have to calculate the magnification. Alright? Calculate the magnification of the image. So the magnification, you know the formula, magnification is equal to v upon u. Alright? M is equal to, v is given there, what is the value of v? We got it as 12 and u is coming, it is minus 24. So it's equal to m is equal to minus 1 by 2. So this is the value of magnification. M is 1 minus 1 by 2. Clear? So you got the magnification. Magnification is 1 by 2. It means that it is the size of the image is half of the size of the object. Alright? Okay. In case of a convex lens. Steps are clear to you? All the steps? Please note down. Now let's start with year 2018 board questions. An object is placed at a distance of 12 centimeter from a convex lens of focal length 8 centimeter. Find the position of the image and nature of the image. Very simple. This type of question we have already solved it. Anyway, let us try to solve it again. An object is placed at a distance 12 centimeter. Object distance is 12 centimeter in front of a convex lens of focal length 8 centimeter. Focal length is given as 8 centimeter. So you know you have to apply the sign conventions over here. So in case of a convex lens, you know the focal length is always positive, u is taken always negative. So what you have to calculate here? First you have to calculate the position of the image. Now let us try to draw a diagram for the more clarity of the case. Over here, take a convex lens, optical center, principal axis, f1, 2f1, here f2 and 2f2 on other side of the lens. F is 8 centimeter, this distance is 8 centimeter, and 2f of obviously it will be 16, twice of f1. Okay, so since f2 we consider the second focal point as the principal focus as the focal length, we take focal length as always 8 centimeter. Okay, this is, we can mark it, this is as 8 centimeter to the right side of the lens. So object distance is 12 centimeter. So this is the total distance will be twice of f1, that is 16 centimeter, right? Object is placed, see where is the object placed? Object is placed at 12 centimeter, somewhere here between f1 and 2f1, right? Because it is 16 centimeter, 12 centimeter, which is less than 16 centimeter. So object will be obviously lying between f1 and 2f1. So let us complete the ray diagram. A ray of light traveling parallel to principal axis. After refraction, it travels through the principal focus. And a ray of light traveling through optical center passes undeviated. It is, see, an inverted image, real inverted image A dash and B dash is formed beyond 2f2, beyond 2f2. And also you know, when the object is lying between f1 and 2f1, image is formed, real inverted and magnified image is formed on the beyond 2f2 on the other side of the lens. You know it, you have studied the case. Okay, so we have to calculate the position of the image. The position of the image you have to calculate. What is this position? V. Okay, so we have to calculate V, that is position of the image or the image distance. Clear? Now how can you solve it? With the help of lens formula, 1 by f is equal to 1 by v minus 1 by u. So we need 1 by v. 1 by v is equal to 1 by f. Taking u to this side, it becomes plus 1 by u. We need 1 by v. Okay, so we need the image distance. Taking u to this side, it will become 1 by u plus 1 by u. Clear? So put the place the values here. 1 by 8 plus 1 by u minus 12. Taking out the LCM, that is 12 and 8, it is 24. 3 8s are 24 minus 2. So 1 by u is equal to 3 minus 2, 1 by 24 plus 24. So u is equal to plus 24 centimeter. So what's the value of v over here? So we are getting the value of v. So it is v, okay, it is v. So the value of v, we are getting it as 24 centimeter on other side of the lens. Okay, first part is over. The value of v is calculated. Second part, what is the nature of the image? So look at the nature of the image. In case real, inverted and magnified. You can write real, inverted and magnified. Correct? Real, inverted and magnified. That's the nature of the image. The steps are clear to you. So this is a diagram. So for your understanding, not necessary that you should draw the diagram every time. Once you know, and if you are confident of solving the problems, you can solve it directly by applying sign convention and solving it with the help of lens formula. Clear to you? Steps are clear? Now moving on to 2017 board question. A lens forms an upright and diminished image of an object when the object is placed at the focal point of the given lens. Name the lens. Draw a ray diagram to show the image formation. A lens forms an upright and diminished image of an object when the object is placed at the focal point of the given lens. So name the lens. So which type of lens can form an upright, I mean erect and diminished image? So erect and diminished image can only be formed by a concave lens. A concave lens can form virtual, erect and diminished image. So we can write the first part, name the lens. Lens is concave. Lens is concave because the answer is already given as hint in the question. Upright and diminished image. Read the question before solving the question. So a concave lens can form virtual, erect and diminished image. Now let us make the ray diagram for the same case. For concave lens, the ray diagram is very simple. For any position, it always forms virtual, erect and diminished image. Let us make a concave lens. Concave lens, very simple. Optical center, principal axis, F1, 2F1, F2, 2F2. Clear? So object is placed at the focal point of the given lens. It is placed at the focal point. Let us place the object here at the principal focus, AB. A ray of light traveling parallel to principal axis. After refraction, it will diverge in case of a concave lens. And if you produce it backward, it appears to be emerging from the principal focus. And a ray of light traveling through the optical center passes undeviated. And the point of intersection is where the image is formed. So we are getting virtual, erect and diminished image A dash, B dash over here between optical center and principal focus. Virtual, erect and diminished image. Clear? So the second part is over. Okay. So this type of numericals are very easy to solve once you understand the concept and remember the lens formula and apply proper Cartesian sign convention. Okay. Thanks for watching.